Hi, let's take another function, kind of like we did in the last video, where we defined a function as sort of a set of a bunch of different functions, and we had this piecewise function definition. As I said in the last video, I'm not too sure how often you really see stuff like this in real life, but you're going to see piecewise definitions of functions a lot because they're pretty useful when you're first getting your head around the concept of taking limits. So let's actually do that again. And let's say I've got a function f of x, and that's going to be equal to, and again, we're going to set it equal to a whole set of functions. And let's do, again, we're going to say that and I'm going to use interval notation here, for minus infinity to 0. And this interval notation, remember I'm using this closed, or I guess it's this open bracket to say that for numbers, and I'm going to say for x, I guess for x's that are greater than minus infinity and up to but not including 0, then f of x is going to be equal to minus x. So that's going to be our first function. And if you remember that, we knew what this looked like. This was just a line with a slope of -1, and then we're going to have this open circle right here, right at the origin, at the point 0, 0, because we're taking all numbers up to, but not including 0 there. So we're going to have that open circle. And then let's say, just like in the last example, we're going to say for... and I'm going to put my closed brackets here to show that it's defined exactly at that point. For x is greater than and equal to 2, comma, I guess you could do it like that. I've never seen interval notation quite like that, but I guess that works to say that we're greater than and equal to 2, and also less than and also equal to 2, or in other words, this is just going to be just at the point x is equal to 2. We're going to say that our function is just going to be, oh, sorry, I didn't mean 2. Those should be zeros, actually. Sorry, I made that mistake. There we go. Zeros. And for that point, for x is greater than and also equal to 0, and also x is less than and also equal to 0. And this might not have been the best way to write it, but I think it still makes sense. We're going to define our function f of x at that point to just be equal to 2. And we remember this from the last video, that this looked just like a point, right at the point 0, 2, right there. So that's how we're going to define our function at the point 0, 2. And then finally, and actually let me expand our brackets just a little bit. There we go. And then finally, the last part of our function, and this is where we're going to make it different than we did in the last video. We're going to say for, what's the interval? So for all x's greater than but not equal to 0 and less than positive infinity, we're going to say that our function f of x is going to be equal to x squared minus 2. So what's that going to look like? That's going to look pretty much exactly like that parabola that we had in the past 2 videos, I guess, except we're just going to shift it down. We're going to shift it down 2 spots. And so you can imagine right here that in the last video, we had the point 1, 1 in our parabola, but if we shift that down 2 spots, it's going to show up right there at the point 1, -1. And then if we're still shifting our parabola down 2 spots, remember at the point we had the point 2, 4, which is right there. And if we shift that down 2 spots, we have a point right there. And I think that'll be good enough for this example right now. And also remember, for all x's up to but not including 0, this part of the function is going to be defined. So we're going to have right there at the point 0, -2, we're going to have an open circle on our graph like that. And then we're going to have our parabola. And that's That's okay. That's, I guess, an okay drawing of a parabola. And so if you remember, and a couple of things just to check out, if we remember our definition of a function, we know that a function, for any value of x we put into a function, we can only get out one value of y. This function can only be defined, can only have one value that it's defined at for each individual value that we put in. So if we look at numbers that are just really almost close to 0, but just a little bit less than 0, they're all going to be defined along this orange line. Then right at 0, there's only one point where the function's defined. It's at this point, 2. And then if we look at numbers that are really close to 0, but then just a little bit more positive, just a little bit more than 0, they're going to be defined along this parabola. So this definition of a function, this piecewise definition of a function, makes sense, and we still do have a valid function. So now my question to you, and we've been working with limits for a little while now, and we've, I guess, sort of established that we don't care what the function is actually equal to at the point that we're looking at. But now my question to you is, what is the limit of this function as x approaches 0 if we're only going to look at numbers that are just a little bit less than 0? That we don't care at all what numbers look like if they're a little bit more positive than 0. So what is that going to be equal to? And you might also ask, well, what would the notation be for that? So I'll show you the notation for that. We would be saying the limit as x approaches 0 from the negative side. So what that means is when we put that little minus sign, as x approaches 0 from the negative side, that's saying we only care, and here let me just write our f of x right there, we only care when we put this negative sign right here. We only care about the numbers that are just a little bit, as we get really, really close to 0 from the negative side. What does x approach? And you can probably see from this, if we're only looking at negative values, so these are our negative values over here, or our values that are just a little bit less than this limit value, a little bit less than 0, what do we approach as x gets really close to 0? And you can probably see that we approach 0 there. And if we're only looking at values that are just a little bit less than 0. Similarly, and you can probably imagine that I'm going to ask you this question now, but similarly, what if we were going to ask, let me choose there's a good color. What if I was going to ask, what is the limit as x approaches 0, but I only want values, I only want to take into consideration the values that are just a little bit bigger. They're just a little bit bigger than 0. I don't want to take into consideration the values that are a little bit less than 0. I only want to take into consideration the values that are just a little bit bigger than 0. And you can probably imagine that notation is going to be the limit as x approaches 0 from the positive side. And that's how we notate it. Limit as x approaches 0 from the positive side of f of x. And now, taking a look at this expression, if we were going to take a look at this expression, the limit as x approaches 0 from the positive side of f of x, what is our function going to be equal to? And hopefully you can see that if we were just completely, what this is saying is we are just completely ignoring all of this stuff over here, all of this stuff on the left side of our graph. So what does this function equal, or what is the limit of this function equal, or what does this function approach as x approaches 0 from only the positive side? And hopefully you can see that this is going to approach -2 as we approach 0 from the positive side. And still hopefully you can see that neither of these values, so we've taken a limit from the negative side that has been equal to 0. We've taken a limit from the positive side that's been equal to -2. And neither of those values is even equal to what the value of the function is actually defined at 2. So it's all Anyway, it's all just stuff to notice, and it's all stuff that's kind of interesting. So in the next video, for right now, hopefully that made some sense to you. And in the next video, we're going to start talking about what it means specifically when these two numbers. So we got different values here to say that if the limit was one number, the limit was 0 if we approached it from the left-hand side, from the values that were just a little bit more negative than our target value. And we got a different number than if we approach from the positive side. And we got -2 here. So in the next video, I'm going to talk a little bit about what it means if these two numbers are not equal. And they aren't equal in this particular example. So anyway, thanks for watching, and I'll see you in the next video.